Hello everybody and welcome to this EKWB and 2CRSI webinar sponsored by AMD. Today we are very excited to have a talk with our partners from EKWB and we will cover an exciting topic which is direct liquid cooling. Of course, we'll also learn more about the partnership between 2CRSI and EKWB. My name is Joanna Blank. I'm in charge of co-marketing activities at 2CRSI Group and I'll be your moderator for today's session. If you have any question, please ask them in the Q&A box on your screen and we'll answer them at the end of the session or later via email. Of course, this webinar is being recorded. We'll send you the recording link after the session so you can watch it again at any time. Now, I would like to introduce our speakers for today's webinar. We are honored to have with us Luka Jakopic, Project Manager for the Enterprise BU at EKWB, and Mehdi Loulidi, Mechanical Engineer at 2CRSI. So, without further ado, I will hand it over to Luka, who will open the floor for us today with a quick company introduction. I will continue with a quick 2CRSI company presentation before handing it over to Mehdi, who will then deep dive into today's topic. Luka, I hand it over to you. Enjoy the session.
Thank you, Joanna. So let me present EKWB first. EKWB has been present in liquid cooling of computers and computer components for more than 15 years. As well as manufacturer, we also are researcher and developer of liquid cooling solutions. We develop over 250 projects per year. We also develop just as much products each year. We expand rapidly, so we have hired more than 100 new employees in the last year. We also received several design awards, EVE Design Red Dot Design Awards, for example. EK is active in 4 different verticals. We are present in DIY, PC building, and modding vertical. So these are components for improving one's computer or installing liquid cooling for personal computers. We make gaming computers as well. Another vertical is maximum performance workstations, which we produce. And we have a custom enterprise cooling solutions vertical, which includes workstations, server, or industrial applications. I come from the custom enterprise solutions vertical, where I work with 2CRSI. Thank you.
Thank you, Luka. To pursue on the 2CRSI side, I'm going to quickly present you the company. So 2CRSI is a French-based company, which is headquartered in Strasbourg in the east of France. We are a group of about 370 people worldwide who are either based in our offices or in our production sites. And since 2005, we've been designing, manufacturing, and selling innovative and green IT solutions, meaning hardware and servers. And this for a wide range of sectors and industries and to address various customer needs. We have a vision. We want to reconcile IT with the planet. So we started by reducing the power consumption of our servers. This already back in 2019, and you'll understand this better in the course of the presentation. And we have already started reusing the heat which is generated by our servers. We are also looking at ways in which we could use this fatal heat as an alternative source of electricity in the future. Moving further, when you think of all that heat that's generated by servers, you can just think of the 4 billion people on Earth who are daily using their smartphones, they're using video on demand, they're surfing the web, connecting to the cloud, just to name a few uses people can make of servers without even knowing it. So the need for servers is clearly on the rise, and these servers are becoming more and more performant and more dense, which means also that they are generating more and more heat. And we need to find ways to cool these servers. So in the data center industry, for example, the challenge is to get the highest watt per square meter ratio. And that can really be tricky for a server manufacturer like TuSerra. So the more you pack heat generating components into a server, the harder it gets to cool them down. And at a certain point, air cooling is no longer a viable solution. And taking it from there, I'm quickly going to cover the 3 cooling technologies that we have available at TuSerra. Of course, there's the traditional air cooling option, if I can say so, which we managed to streamline thanks to our Octopus range, which Mehdi is going to come back on. Other than that, well, we have what we're going to focus on today, and we'll come back to that in a second, which obviously is direct liquid cooling, a combination of air cooling and direct liquid cooling. And finally, I just need to underline the fact that immersion cooling is a trend which is on the rise, with those servers becoming more and more dense and generating more and more heat. So this is also an option which is perfectly viable for server solutions. But this is not the topic of today's session. We're going to focus on direct liquid cooling, and I'm now going to hand it over to Mehdi, who will speak about our approach as far as direct liquid cooling is concerned.
Thank you. So hello, I will start by presenting you our Octopus 1.4e DLC server, which is a 21-inch server that is available in our portfolio of OCP servers, which are 21-inch servers. And you can see them on the presentation. There are several options. The 1.4e is DLC, like liquid cooled, and the other one that you can see are for the moment used in air cooling or in immersion cooling. So the Octopus 1.4e is a one OpenU server, which means it's one rack unit high, and it's equipped with one motherboard, and it disposes of one AMD SP3 socket, which you can equip with EPIC CPUs. There is also 4 GPU. Currently, it's Vega 64 GPU by AMD that we are cooling with direct liquid cooling. The full specification of this server are available on TuSerra website for more information. So the first focus will be on the power distribution module that we developed for the servers. So there are 3 power distribution boards at the rear of the servers. This power distribution board gets the 12-volt DC from the bus bar that are present at the rear of the rack. So you just have to push the server inside the rack, and then the power is coming through the power distribution board and is delivered to all the components inside the server, thanks to the several connections that you can see on the picture. You can put a lot of cables to deliver power to each component. And one of the main advantages of using this kind of power distribution is that there is no PSU power supply unit inside each server. So all the power supply are mutualized inside one power shelf or more on the rack, at the rack level. And the power is then delivered by the bus bars. So you don't have any power cords that connect the servers and the power distribution unit available on the traditional architecture of rack. And you don't have to go on the hot corridor, so on the back of the rack, to be able to connect or disconnect a server. You only have to be in front of the rack, and you can remove a server, for example. You just pull it and it disconnects the power. So it's in the same approach that at 2CRSI we developed our liquid cooling solution. As you can see, there are a manifold at the rear of the rack, and there is the coolant distribution module. So there are two coolant distribution modules at the rear of the server, and it's the same thing for the power module. You only push the server inside the rack, and it connects to the power and to the cooling system, the water cooling system. And so forget the hose jam and the cabling jam at the rear of the rack. There is no cables and no hose at the rear, and you don't have to go on the back on the hot corridor. And it's possible thanks to the blind-made self-aligning and dripless couplings that we have on our coolant distribution modules. So once you push the server, it connects to the cooling system, and the flow of water is going through the server. And if you want to remove the server, you only pull it, and it disconnects from power and water. So it's the Open Compute, the OCP version of IT. So inside the server, there are several flow paths, and as you can see on the screen, there will be an animation with the flow which is distributed to all components. So in blue, it's the cold water that is distributed to components. Then it's going through it's taking the heat from the GPUs and CPU, and it's going to the next component, and then it's going out of the server. There is one input and one output. And yes, so the water is flowing through the component and is taking the heat from this component. So you can see one more time the animation of the flow inside the server, in case you didn't see it very well at first look. So then we will speak about the diagram of heat, water, and air flows to be more clear on this topic. As I said, there are the GPUs and CPU that are equipped with cold plate, and then the heat flow from this component it is transferred to the water by the cold plate attached to them. Then, as you can see, the hot water removed from the cold plate attached to the CPU and GPUs is transferred at the data center level, or it can be at the rack level, but for my example, it's at the data center level, to the CDU, it's the coolant distribution unit, which is then which transfer then the heat to the dry cooler or the evacuating heat system of the data center. Then there is also the DIMMs, for example, or other component inside the server, like, I don't know, a PCI card or this kind of component or storage. And these components are still cooled by air, like you can see. And our fans are not at the server level, but at the rack level. And then the heat is carried by air to the ambient air of the data center, which is handled by the CRA or crack unit. And it's approximately 80% of the heat which is captured by the water, and 20% of the heat which is captured by air. But this value are variable depending on the configuration of the server. If you have more components like DIMMs, it can go up or down, it depends. And when I said water, for those who don't know very well liquid cooling, it's not really water, it's water with additives like glycol, for example, or anti-corrosion, antibacterial, this kind of products. So now I hand it to Luca, who will make more focus on the cold plate subject.
Thank you, Mehdi. So I will talk a little bit more about direct liquid cooling cold plates. We traditionally call these blocks the water blocks, even though, as Mehdi explained, it's not necessarily just water running inside of them. Nickel-plated copper cold plates of water blocks have a dense microfin structure that ensures cooling efficiency. So this dense microfin structure that actually increases the surface that the cooling liquid touches, and it transfers the heat more efficiently to the cooling liquid. CPU water block cools the CPU through the contact with the CPU integrated heat spreader. Thermal paste is used to ensure the thermal conductivity and proper contact. GPU water block directly cools the GPU, processor, VRAM, and the voltage regulation module and its components. Thermal paste is used to ensure the connectivity with the GPU processor. Thermal pads are used to ensure the connectivity with VRAM and voltage regulation module components. On the left side, you can see the CPU water blocks, and on the right side, you can see the GPU water block. This side is showing the cold plate with microchannel structure. On the right, you can see the simulation, a graphical representation of the simulation. As you can see, as the liquid touches the microchannel or microfin structure, it flows through these fins, which increase the contact surface of the cold plate with the cooling liquid and ensures the proper cooling of the processor below. Why liquid cooling? As well as benefits of liquid cooling compared to air cooling, liquid cooling is also one effective means to reduce the thermal throttling of the computer equipment. It prevents performance bottlenecks. This in turn increases the consistency and performance of the system, as well as increases the lifetime of the system by preventing damage to the electronics that would be caused by thermal spikes. You can see the graph on the right. So here we have a line for liquid cooling systems and air-cooled systems. The thermal throttling has been set at 60 degrees. And you can see that air cooling does not prevent the spikes, while the liquid cooling prevents the spikes. So let's look at the professional line of blocks used in Octopus servers. The first is the EK Pro CPU water block designed for AMD EPYC CPUs. It's a block designed for low profile in-rack installation for various AMD socket processors. For the GPU, the Octopus has EKFC AMD Radeon Vega series water block. You can see the block with the GPU from the top, and on the bottom you can see the other side of the block, which shows the cold plate surface, which actually comes in contact with the GPU processor, as well as VRAM and voltage regulation module.
So thank you, Lucas, for this focus on the cold plate topic. And I will now present you the global solution proposed by TwoSeriesI for the liquid cooling. Because at first I'll present you the Octopus 1.4e server, but we also proposed a full rack and the rack level cooling system attached to it. Because at TwoSeriesI, we are manufacturing our own racks on several heights, like 12 OpenU, 26 OpenU, and this kind of height. And this rack are accept 19-inch servers and 21-inch servers in the same enclosure. We have add-on parts that we can add or not on the rack to be able to add different servers. So now I will present you the Octorack 30 DLC ready. There is as you can see, there is the rack on the screen. It's a 41 OpenU rack, and it's capable of carrying 30 servers. As you can see, there are the fan wall that is equipped with 18 rack level cooling fans, and there are also the manifolds on each side of the fan wall. There are also automatic air purge to be able to remove the air from the system. And there is one entry on the bottom of the rack and one output on the bottom of the rack too, but it's possible to have them on top. So there is a video presenting you the system in it's the prototype that we are working on, and we are currently testing it, making some advanced tests. And yes, you can see on the little video that is playing now that there is also the 12 OpenU version of the rack. It's a very small version that is also equipped with liquid cooling. Next slide presents you the rack that I was talking about. It's called the MiniRack 12 OpenU DLC ready. It's composed like the big one with a fan wall with 6 fans for this one. And there are a cold manifold and warm manifold with the input and output at the bottom or top, like it's needed in the integration. It's also possible to stack several mini racks, one on top of each other. And one advantage is that you can equip one rack with a 19-inch add-on part to be able to populate it with 19-inch servers, and you can keep one of the 12 OpenU racks stacked with, for example, stacked upward. You can keep it in 21-inch size, so you will be able to have your traditional 19-inch server, and you can explore the 21-inch OCP world with our server. There are the specification of the rack. So as you can see, it's not really high. It's only 800 millimeters high, and you can go up to 15 kilowatt with this rack. It's for high density, and yeah, it's 12 volt DC, like all of our solution based on Octopus. So as I said before, next to the fans, there are the distribution and collection manifold. So the distribution manifold is carrying coolant inside the server. It's the cold coolant, if I can say so, because the cold coolant can be up to 45 degrees or even more. And then there is the other manifold on the right that is carrying the warm coolant outside of the rack. The warm coolant can be up to 60 degrees or 65. It can be possible depending on the server configuration. This manifold are equipped with blind mate couplings that will mate with the server. And as you can see on this slide, there is the flow that there will be an animation. There is the flow that will go through the manifold and then is distributed to all the server along the height of the rack. Inside each server, there is a little block. It's the interconnection block which is dividing the flow and split it to be able to give cold coolant to each server, each component inside the server. And here you can see the full height manifold and a small video with the connection process. You can see the PDB, the power distribution module, and the coolant distribution module that connect at the same time. And you can also notice that the couplings for the coolant distribution are mating with the misalignment option. It means that you can see it now. They will auto align each other to be able to provide the coolant path. And it's dripless. It means there is not even a single droplet that will fall from the connectors, the coupling, so no risk for IT gear. And for the future, liquid cooling will become more and more an evident solution, because the TDP will be more and more high, because the CPU and GPU TDP will go high and the temperature allowable by DES will go down. It's the future trend for the CPU and GPUs. And so if you will have to have lower temperature at the entrance if you want to cool them by air. And at the time, it won't be possible to cool it by air, because it will demand too much space and too much power to have cold air inside the server. So the liquid cooling won't be an option anymore. It will be a necessity. And I will let now Luca finish by presenting you some of the cold plate from EKWB.
Thank you, Mehdi. Professional line of blocks from EK, as I've said before, we split them on CPU and GPU blocks. We do follow the AMD developments closely, and we develop new blocks as new processors come out. As AMD is keeping at least a mechanical part of socket compatibility, this development can go really fast, and we can follow AMD very closely. For the EK Pro line of blocks for the latest GPUs, we try to keep the low profile for in-rack installation. We also try to make the blocks as thin as possible to enable the single slot installation of the GPUs. So for example, if you have a motherboard that enables 7 GPUs, you can stack 7 GPUs which are water cooled into your system. Right now, these blocks can cool the graphic cards with TDP up to 380 watts. And of course, we can go even higher. Thank you. This is all from my side.
Thank you very much, Luca and Mehdi.
Thank you.
Thanks a lot for listening, and I hope this session was useful to everyone. What we'll now do is that we'll take some time to answer a few questions. I saw several coming in, so like I said earlier, we may answer just some of them, and after the session, we'll get back to the other questions via email. So the first question we have here is for you, Luca, and is the following. How do you ensure the water block reliability?
We manufacture our blocks at our factory in Slovenia. Each block is tested after it's manufactured for any leaks. We use compressed air for this. We can test at the different pressures. Of course, if the pressures are higher, we have to test with the liquid to prevent any danger or damage to either equipment or our employees. So we basically do ensure that each block is tested for any leaks, and we make sure that it wouldn't leak in your inside of your server.
Perfect, thank you. And I have another question, which is also for you and also linked to the water blocks. Can you give us an idea of the lifetime of a water block?
Water blocks are very reliable. They have been used for personal computers before. So usually with the regular maintenance, the water block will actually have a lifetime which is longer than usability of the component which is cooling. So, for example, CPU will become obsolete faster than the water block will will reach end of lifetime. So with regular maintenance, replacing the coolant to prevent fouling or clogging, the water block can outlive the components it's cooling. It's quite common that people who decided to have a new CPU, they would replace the motherboard and the CPU, and then use the old water blocks to cool the new equipment.
Perfect, good to know. Thank you. And we also have a question for Mehdi. Mehdi, can you tell us if it is possible to make heat reuse with direct liquid cooling?
Yes, it's really possible with direct liquid cooling because the liquid, is a good media to be used a good medium to be used to carry the heat, and then we can reuse it on with different possibilities. For example, it's possible to heat a pool, or maybe vegetable greenhouse producing factory, or this kind of system that needs heat all the time. It's also possible to have a cooling district system connected to the data center. So the heat will be used for the heating of the apartment, of the neighborhood, or this kind of things. We are also planning to use the heat from the servers to create electricity from it. But for the moment, the solution available on the market to do this are not efficient enough, at least economically, to be used for the production of electricity. But at TrueCRSI, we have an R&D department, and we are working on a lot of topics, and this is one of the topics we're working on.
So we are now reaching the end of the session. Thank you both, and thank you very much, everybody. As I said, more webinars will be coming, but in the meantime, what you can do is that you can visit our digital touchpoints, websites, and social media. Please don't hesitate to follow us on LinkedIn and Twitter, and stay tuned for more webinars. Enjoy the rest of the day, and thanks again for connecting with us today. Thank you.
Thank you.
Bye.
Thank you. Bye-bye.
Goodbye.